Okay, girls, do not swear. Okay, so we were on to all that empirical rule stuff was fine, was it? All the questions you did this morning, up to number 11 when I started to mention Z-scores. Okay, so I need to explain what a Z-score is to you, right? Okay, so okay, right. So what we need is, right, okay, you know the way we have our surveys that fit a normal distribution, okay? So what we need to be able to do is to standardize them, so we can take a value of one survey, right, and take a value of a different survey and say which is best. As in, we can take a value of your English test, we get the mean and the standard deviation of your English test, right? We get the mean and the standard deviation of your maths test, and we can compare then, oh look, I got more marks in maths, but I'm actually doing better in English, right? Okay, so Z-scores allows you to compare different surveys, right? Allows you to compare different surveys. So the standard normal distribution, okay, so the standard normal curve, right, the curves we've been looking at, some of them have been wider, narrower, flatter, etc., right, but the standard one, the one that everything gets compared to, is called the Z distribution. It's a special normal distribution where the mean in the middle is 0, right, so the mean is 0 and the standard deviation is 1, so the steps are 1 up and 1 down, okay? So this is a standard normal distribution, right, okay, and basically we're going to take our values and we're going to make it fit this, right? Every normal distribution is a version of this standard normal distribution, right? So whether it's flatter, wider, more peaked, etc., right, that is being stretched or squeezed and moved horizontally left or right. So the mean might be 50 or the mean might be minus 20. Whatever, okay, so it's moved horizontally left or right, and the standard deviation means it's squeezed up a bit, right, okay, if the standard deviation is smaller than 1 and if the standard deviation is bigger than 1, it's been stretched out a bit, okay. While individual observations from normal distributions are referred to as X, there is referred to as Z in the Z distribution, okay. So, you know, X, right, okay, when we were talking about what we were talking about this morning, the mean time it takes to go to work or something like that. Remember one of those questions? We would call that X, the mean time to go to work was X, and one fella took 45 minutes to go to work. We called 45X or whatever. Okay, now on the Z normal distribution, everything is called Z. Okay, right, so we're going to take our X value from our survey and we're going to turn it into a Z score, as in we're going to play around with it, we're going to use a formula and we're going to turn it into a Z score, as in we're going to say, well, this would be in this place on the normal Z distribution, right, okay? So it'll make more sense in a minute when we see the formula and start doing it, and you'll realise it's not as bad as you think it is, right, okay. Z scores tells you how many standard deviations away from the mean each value lies, okay.
What does individual observations from normal distributions
from normal distributions, you know, when we were doing the question this morning about the time it took to work, A normal, we were looking at 47 minutes. How many people took longer than 47 minutes? That 47 minutes is an individual observation from that distribution. Okay? Right. So it's just a value from whatever distribution you're looking at. We called it X. Right? Okay, but now we're going to turn it into a Z value. So we're going to take our curve, whatever we got, and we're going to make it fit this normal curve. This normal, standard normal curve that has a mean of 0 and a standard deviation of 1. And as I say, once all the writing's done and we actually do a few bits of this, it'll make a lot more sense. Right, and we need our log tables for this. Right, we good? No. Ready? Yeah? Going, gone. Right. We only need to know the mean and the standard deviation of your distribution. So our survey, we need to know the mean and the standard deviation of it, and then we can find a Z-score that allows us to compare all surveys, right? Okay, so it kind of fits them into this standard normal distribution, right? And then because they're all in the standard normal distribution, we can compare different surveys, right? Okay. And the Z-score there, how you calculate it is X, that's the value from your survey. So the 47 minutes to get to work, or whatever it was, right? Minus mu, mu stands for mean, right? And sigma is the standard deviation, and this formula is in the log tables, okay? So the Z-score formula is in the log tables, right? So you don't need to learn it. Well, you probably will, you're going to use it so many times, you know it. So it's X minus mu all over sigma. Right, so the easiest way to show this is, sorry, ready?
Yeah.
It's okay. Speak though. What if I miss that reaction? It's a very startling reaction. She took it very bad.
What is the score or value like? What?
Z-score, it's just a value.
What is X is in, you know when you say
X
X
is,
score or value? Is X the individual observation?
yeah.
Okay.
So X is what the result you got from your survey that you want to investigate.
The result that you want to make into a Z-score?
Yeah, to see where it stands in the scheme of things, in the overall picture, right? Because in your survey, it might be a maths test score. In your survey, it might seem really good, but when you put it into a Z-score and compare it to your English and your Irish and your geography, it might seem like you're doing really bad at maths, even though you got 85% in your test. Do you know what I mean? So it allows you to compare different surveys because you're putting all your surveys into this standard normal distribution, right? Okay, so X is the score or value you're investigating. So the mark in your maths test, right? Mu, you'll be told it's the mean of your distribution, your survey, right? And standard deviation, you will also be told or be able to calculate, right? Is that okay? So we're going to turn these into Z-scores, right? Okay, and then we'll move on from there. In the normal distribution, the mean mu is 80 and the standard deviation is 4. Convert each of these values to Z-scores. Do it. Right, so you need the formula. Where's my computer pen? My computer pen. No, that's not it. I am. I told you not to swear, but you swore anyway. So. When I started recording and you were all talking and no one was listening to me. Yeah, I took it bad. Right, computer pen on the missing list. Straight in front of me. Right, okay, so Z-score, formula Z-score equals X minus mu all over Z. God, that's really bad. That says X minus mu all over Z. So X is the value you're checking out. So it's 84. Mu is the mean, take away 80. Divided by 4. And into the calculator of that and you get 1. Did you get Z-score 1? Right, we'll talk about what you do with the Z-scores in a minute. Okay, so the next one is 72 minus 80 divided by 4, which is minus 2. The next one is 86, take away 80 divided by 4, 1.5. Yeah, and the last one is 70, take away 80 divided by 4, 0.25. Minus 0.25, is it? Minus 0.25? 2.5, minus 2.5, sorry. Is that okay? Say that again? And that's supposed to be a 4. It's supposed to be a sigma. Yeah. Right, okay. So it's supposed to be a sigma. So x minus mu all over sigma. Right, are we happy with those? We'll see y z-score in a minute, okay? We're learning how first, we'll see y. Y coming up. How? Done. Y coming up. Okay? Right? Are we all right? Moving on? Are we all okay with those? So what do we say the answers were? 1 minus 2, 1.5 minus 2.5. Yeah? We all got those? Don't have to do out any of those, no. Right, okay. Right, the standard normal distribution, this is mean of 0 and a standard, don't write this a minute. Between the standard and the z-axis is 1. Lads, what is... Just write turn z-scores to probability, right? Write down the last sentence there, right? Okay. The area that reads. Actually, write them all. This has. Yeah, write it all. It's important. This has a mean of 0 and a standard deviation of 1. We've that written already, but it's no harm. Right, the area between the standard normal curve and the z-axis is 1. Right, the z-axis is the horizontal axis. Right, okay, so the area under the curve is 1. Right, okay, and area, what else adds up to 1? So the area, if you get the area under the curve, it's 1. What else is 1? The total what? Probability, isn't it? Okay, so the table on page 36 or 37 of the formulas turns z-scores to area or probability, and we'll turn them to probability, okay, because that's what we'll be using. So we'll be using the table on page 36 and 37. Area. A-R, I supposed to put an A in front of it. My magnificent writing. It's really hard to write when it's straight up like. So the area between the standard normal curve and the z-axis is 1. That word, second point.
No, the third one.
The table on page 36 to 37 of the formula and tables turns z-scores to area or probability. Yeah, tau was supposed to be 2. Tau was supposed to be 2. Yeah. It's when you dictate in PowerPoint in a Tipperary accent. That's what comes out. When you say 2, they read 2. Right? Conversation means we're ready to move on, does it?
Yeah.
Basma, ready? No.
I'm just writing the tables.
Right, you're okay? Right. Okay. Example. Find the probability that z is less than or equal to 1.68. Right, okay. Stop a minute. Right, okay. So, have you got your log tables?
Yeah.
Will you open your log tables on page 36 and 37? Right? So, what we're doing is, right, okay. What we're doing is, we're taking our value from our scores, from our log tables, from our survey. We're making it fit the normal curve, so we're turning it into a z-score. That means the z-score means if it's somewhere on the z distribution where the mean is 0 and the area under the curve is 0, right? Okay, and this is 0 is in here because the mean is 0, and the z-score fits in here somewhere. So it'll either be a 1.68, it'll be 1.68 steps up this way, or it might be minus 1.68 steps down there, right? We can find the probability. So the first one there is 1.68, isn't it? Yeah, sorry. So the first number there is the probability that Z is less than or equal to 1.68, yes? Is that what the thing is? Yeah. Right, okay. The table tells you Z scores, right? Okay, and it tells you the probability that the Z score will be less than this number. So 1.68, all you have to do is look it up. 1.68, the probability of 1.68, I'm looking at, am I looking at the right one? 0.9535, do you all see that one? 0.9535?
Yeah.
Yeah, and if you want a log table, there's one here. If anyone else needs a log table, there's one up here. Will you throw out one in the, throw out the box there? So we're on page 36, 37. Does anyone else need a log table?
Yes.
Right, so the probability that Z is less than or equal to 1.68, that's what the table tells us. So it's 0.9535. So the probability that the value you picked is within this bit of the curve is 95.35%. So you have a 95.35% chance of the number you picked from your survey being right on, being below 1.68, right? Okay, it's always below, right? Okay, so it's always below. So what if I said, what's the probability that the Z score is greater than 1.68? Remember, this is a percentage, right, or a probability. What do all probabilities add up to? 1. So how will I find out the probability that it's greater than that number? Take it away from 1. So it's 1 minus 0.9535, which would be 0.0565. Right. Okay, bear with me for a minute. Yeah, it's weird for a minute. Okay, but it'll be easy in a minute. Okay, so you turn your values into a Z-score, right? Then you can find on your table the probability that your X values, your 84%. So just imagine it was 84, right? Okay.
Your Z score was 84.
Your original score was 84. Your maths test,
Yeah.
right? That I did, right? Okay. So you got 84% in your maths test, right? Okay. And I turned that into a Z score, right? Okay. So you want to know, right? Is this good, bad? Am I good in the class? Am I bad in the class? Right? What's the story? Right? Because 84% is fine, is really good, but if everyone else got 99%, there's a problem, isn't there? Right? You're not doing as well as everyone else, right? Would you agree?
Yeah.
Right. Okay. So what you turn the value, maybe I might change it to 64% because 84%.